Hello! In our previous module, we learned about the idea of subderivations. In this module, we're going to start learning a little bit about strategy with subderivations, and in particular, we're going to learn about two main kinds of subderivations to do and the situations in which to do them. And they're involved when you're trying to show either a conjunction or a conditional. So the first strategy we're going to learn about, and we'll learn about that in the rest of this video, is called show cons, and we'll see what that is. But you use this when you're trying to show a conditional. When you already have a show line and it's a conditional, then show cons is a good subderivation to do. The other kind of subderivation, and we'll learn about that in the second video, is called show conj, and that's helpful for when you're trying to show a conjunction. So in this video, we're going to learn about show cons. So let's actually go ahead and see how it's used. So here we have a fairly straightforward derivation, one actually you might have already done, or someone like it. So let's say go ahead and we'll show the conclusion. The conclusion is a conditional. There's its main connective right there in the middle. The antecedent is itself a conditional, P arrow Q, and the consequent is also a conditional, not Q arrow, not P. So our first step, as usual, would be to say assume CD, and we're going to go ahead and do that. Whenever you can do assume CD, you want to. Now, we would put in any premises, but we don't have any. So all we have is P arrow Q. And while we could apply double negation to our, to no end, to our heart's delight, on 2, it wouldn't get us anywhere. And there's nothing really else we can do here. So the derivation is stuck. And when a derivation is stuck, you want to do a subderivation. And so you want to do a subderivation that will help you complete the derivation. And what might that be in this case? Well, the natural thing to do, the most natural way to box and cancel this would be with CD. And what would we need to get if we were going to box and cancel with CD? We would need this. If not Q, then not P. And that's the consequent of this derivation. So the natural thing to do is we would write show and then punch in if not Q, then not P. And that's correct. But instead of having to do that copy and paste, we can do this. We can say show, and then we write consequent. So here we have show conc for show conclusion. Here we're going to write show cons, show cons for show consequent, because if we can get we're trying to show a conditional on line 1. If we can get its consequent, then we can apply box and cancel to that consequent, and that will box and cancel that first show line. So we think, okay, well, what I want is if not Q, then not P. What we want is if not Q, then not P. So let's try to show it. Let's try to show the consequent. We're trying to show this, so let's do a new subderivation. Let's try to show the consequent of line 1. And that's what show cons does. When you have a show line, then you can put in you write show cons, and it will write in a new show line, which is the consequent of the original show line. So now we have our new show line, show if not Q, then not P. Well, if we can make an assumption we want to, and we can, so we're going to say assume CD. Gives us not Q. Okay, can we use not Q? Yes. We can't box and cancel with it, because we need, if we're going to box and cancel with CD, we would need not P, that being the consequent of line 3. But we can use MT with 2 and 4. So we can say 2, 4, MT, because 4 is the negation of the consequent of 2. And that will give us not P. And hey, that is the consequent of line 3. And so we can apply CD to line 5. So we'll say 5 CD. And remember, you have to box and cancel whichever show line is the nearest one, the last one that you started. And so that means we have to box and cancel this first, and then we'll get to box and cancel that. But we can apply CD to line 5 to box and cancel line 3, because 5 is, in fact, the consequent of line 3. So we'll say 5 CD. That boxes and cancels line 3. So now we can close up line 3, because this reasoning in fact does rely on this assumption, and even if it didn't, it might have, and we don't want to use any such reasoning. It's fine to rely on this assumption as long as we're trying to show this, but once we're done trying to show line 3, we don't want to rely on that assumption anymore. And since this reasoning does and certainly might have relied on that assumption, we don't want to use any of that reasoning. But we do want to use line 3. Now that we've canceled the show line, we want to use it. Whenever you do a subderivation, whenever you complete a subderivation, whenever you box and cancel a subderivation, you immediately want to use the sentence that you just showed. The point of doing the subderivation was to get you the sentence, and then you want to use the sentence. So we just got line 3, so we want to use line 3 now. We might not remember why, though. Why was it a good idea to get line 3? What was the point of that? Well, one of the nice things about these show commands, besides the fact that they write the show lines out for us, is that they tell us why we did the subderivation. In this case, this says show cons. And when you do show cons, you say, oh, well, if I'm trying to show a conditional, then I'll try to show its consequent. And once I have its consequent, I can apply CD. So whenever you complete a show cons subderivation, you know, oh, I just showed the consequent of a conditional that I was previously trying to show, and so now I can apply CD to the thing I just got to box and cancel the initial show line, right? Because that's what this is. 3. This is the consequent of this, right? Here it is, there it is. Here it's by itself. Here it's busy being the consequent of our first line. So what we have on line 3 is the consequent of line 1, and so we can say 3 CD, and that boxes and cancels line 1. There we go. So that's how we use show cons. We use it to say, I've got the consequent. I'm going to try to show I'm trying to show a conditional. Let me try to show its consequent, so that when I have, I'll then apply CD to that consequent to box and cancel the initial show line. So if you have show, box, arrow, circle, if that's what you're trying to do, if you have that as a line, uncancelled, right? Then what would you do? Well, the first thing you would do is you would get box with assume CD, and then somehow or other you would try to get circle, and then having gotten circle, you would apply CD, and that would box and cancel your show line. And of course the question is, how do you get circle? Well, we now have a new main way, namely this show cons approach. We would say show circle, we would make another assumption if we can, and then eventually we would box and cancel show circle. Having done that, we can then box and cancel the initial, we can cancel the initial show line because now we got its consequent. And so what that looks like is, if you want to show box, arrow, circle, then and the key thing here is immediately box and cancel box, arrow, circle once you get circle, right? As soon as you complete that subderivation, you would use circle to box and cancel the whole thing, since that's your ultimate goal. So this is what it looks like. You'd say show, box, arrow, circle. You'd say box, assume CD. And then you'd say show circle using show cons. You do whatever you do to get circle. You box and cancel that line, box and cancel line 3. However you do, it's going to depend upon what circle actually is. But then, having done that, you can then say 3 CD, and your entire derivation is complete. So you don't always have to show cons, but it's never wrong. It might make your derivation longer than is necessary. You've shown lots of conditionals without having done show consequent, but it will never, doing show consequent will never send the derivation in a wrong direction. It will only, at worst, give it a few extra steps. So if you want to show box, arrow, circle, show the consequent circle, and use show cons to do it. So let's look at another example of this in the derivations module. This time we're trying to show, again, it's another theorem. We don't have any premises, but we want to go ahead and say show the conclusion no matter what. And this whole thing is a conditional. There's the main connective, there's the main conditional. So we'll go ahead and make our assume CD assumption. Now, as I just said, it's a theorem, so there are no premises, so we can't bring any premises in, and we can't do anything with line 2, and so the derivation is stuck, and that means we need to do a subderivation. What should we do a subderivation of? Well, whatever will let us complete the main derivation, whatever will let us box and cancel line 1. What will let us box and cancel line 1? Well, the consequent of line 1 will let us box and cancel line 1. So let's try to show the consequent of line 1. Okay, so good. Now we're trying to show if Q then R, only if P then R. Okay, well, again, we want to make an assumption whenever we can, and because what we're trying to show is a conditional, we can make an assumption, so let's go ahead and do that. Okay, so now we have a new sentence. So now we have two sentences. We have P arrow Q and Q arrow R. But we're still not that much better off. In particular, we can't apply any helpful inference rules. We can't do MP with 2 or 3. We would need P for MP with line 2, and we would need Q for MP with line 4. We can't do MT because we would need negation Q for MT with line 2, or negation R for MT with line 4, neither of which we have. So we can't do MP or MT. So we're and we can't do any useful, addition, or we can apply addition, adjunction, and we can apply double negation, But those aren't going to help us. So we're stuck, and we're stuck because the derivation is stuck. And when the derivation is stuck, what should we do? We should do another subderivation. What should we do a subderivation of? Well, hopefully something that will help us complete the show line we're working on. So right now we're working on line 3, so we want to do a subderivation of something that will help us box and cancel line 3. And that'll be good because once we box and cancel line 3, we'll then immediately be able to use it to box and cancel line 1. So we're working on the line 3 show line. That's the closest one. It's the one that's highlighted in gold, and that's the one we want to, so that's what we want to box and cancel. So we want to do a subderivation that's going to help us box and cancel line 3. Well, line 3 is a conditional, so what should we do? Well, if we get its consequent, we can apply CD, so we should say show cons again. But this time, we're going to show the consequent not of line 1, that's line 3. Now we're going to try to show the consequent of line 3, and that's P arrow R, right? This is a consequent of that. And now, wait, now we have 2 subderivations? Yes, you can do. You can write a show line whenever you want. So you could write as many show lines as you want, and you could just keep going and going and going. Then that would be like, we could say 4dn, and then we could say 6dn, or 6, dni, and then we could say 7dni, and then 8dni. That's pointless, but we could do that. Similarly, we could say, okay, well, I don't know, now maybe I'm in the mood to show z. Now maybe I'm in the mood to show if z, then p. Now I'm in the mood to show p and not q. Sorry, that should be and so on, right? You can make as many show lines as you like. There's no restriction on introducing them. The problem is you wouldn't be able to box and cancel these, but you can add them. Okay. So we've added a second show line, or a third show line, a second subderivation. So it's a conditional, which means we can make a conditional assumption, which we want to do, so we'll get P. So now we want to ask, can we use P? And indeed we can. We can use P with line 2. We can say 2, 6, MP, because P is the antecedent of line 2. That gives us Q, and what can we do with Q? Can we do anything with Q? Yes, we can do modus ponens with line 4. We can say 47 not 47, 47 MP, that gives us R. Can we do anything with R? Yes, we can. R is the consequent of line 5. So we can apply CD to line 8, to R, and box and cancel if P then R. Good. Okay, so now we've completed this. So we've completed we've box and canceled one of our show lines. Of course, we have to box and cancel the rest. So having box and canceled this one, we're now on line 10, and we're back to working on line 3. That's now the nearest show line. So we're going to go ahead and close up line 5 because we can't use it anymore because this stuff, we can use line 5, we can't use 6, 7, 8 because they may rely on this assumption, which was fine to use as long as we were trying to show if P then R, but now that we have shown it and are no longer trying to show it, that assumption is no longer legitimate, and so any reasoning that might rely on it, we cannot help ourselves to. But that's okay because we've gotten if P then R, which is what we were trying to get, and now we don't need that reasoning anymore. But why were we trying to get if P then R? Well, we may not remember, but that's okay because we can look over here, remind us this says why we showed line 5 and what it's show cons, and that tells us that line 5, what we have on line 5, is the consequent of the previous show line. This is the previous show line, and indeed, here's line 5 if P then R, and hey, if P then R, that's consequent of line 3. So because this is show cons, what we have on line 5 is the consequent of the previous show line, and so we can apply CD to it. When you have the consequent of a show line, you can apply CD. Okay, good. So now let's close up this. Again, if we don't remember why we did line 3, why we tried to show if Q then R, then if P then R, well, we can look over here. This tells us it's show cons. Oh, that's right. 3 is the consequent of line 1. Well, because 3 is the consequent of a line 1, we can apply CD to it, and that boxes and cancels line 1, and our derivation is complete. So this shows that you can do multiple subderivations. Then you can do multiple subderivations of the same kind. You can do show cons repeatedly. Of course, since you're doing it to new lines, right here when we say show cons, we're trying to show the consequent of line 1, and that's this whole thing. Here when we say show cons, we're trying to show the consequent of line 3, which is just this. So each time we do show cons, because we're working on a different show line at the point in which we say show cons, we get a different show line. And so we can apply show cons repeatedly. This strategy, if you want to show box, arrow, circle, show the consequent circle, and you can set that up by saying show cons and doing a subderivation. This is a very powerful strategy. You're going to need to use it in your homework for this module and future homeworks. And you want to remember that multiple subderivations are okay because you can write as many show lines as you want. There's no restriction whatsoever on writing a show line. And as we just saw in the derivation we just did, they are sometimes necessary. Okay, so that's show cons, which is helpful for showing conditionals. In the next video, I'm going to talk about show conj, which is helpful and sometimes necessary for showing conjunctions.